Good morning, this is Mr. Precella, and today we're going to be looking at some exponent rules, beginning with the definition of a zero exponent. Anything to the zero power is 1. So on problem number 1, it says negative 29 to the zero power. Well, anything to the zero power is a 1, so the answer is just 1. Right? Sometimes students don't really believe it unless they see it in a calculator. Let me see, if I go parentheses, negative 29 raised to the zero power. This is the little exponent key. 0, there it is, 1, right? Anything to the zero power. 256 raised to the zero power is not 0, it's 1, okay? Now, we have some the definition of negative exponent. A to the negative n power a negative exponent means 1 over a to the n. A to the negative n is 1 over a to the n. For instance, 5 to the negative 2 power is not negative 25. It's not negative 10. It's not negative anything. It's 1 over 5 squared. Or we could write it as 1 over 25. There's a corollary to that. If you're going to raise a fraction to a negative power, rather than going 1 over the fraction, you can just flip the fraction, or take the reciprocal, and change the sign from negative to positive. Okay? A fraction to a negative power. Just flip the fraction and change the exponent to positive. For example, if we had something like this, 2/3 to the negative 2 power. We could write that with a positive 2 exponent just by flipping the fraction, and then 3 squared is 9, 2 squared is 4. Let's do more problems. Like problem number 2. We have a fraction to a negative power. So that's what I was just doing right here. Just flip the fraction. Flipping 1 over 6, I get 6 over 1. I think I'm just going to write that as 6. And then change the sign of the exponent from a negative 2 to a positive 2. So 36, is my answer there. Now, let's see. Let's see, hold on. I'm trying to rearrange these pages. Just bear with me. There we go. Now problem number 3 says 3 over 4 to the negative 3rd power. Oh, I'm sorry about that. There it is. Well, I'm going to be using that same rule that I was using just a moment ago. A fraction to a negative power, you could just write as the reciprocal to the positive power. So there's 3 over 4 to the negative 3. I'll write that as flip the fraction, positive exponent, and I'll play calculator. 4 to the third is not 12. 4 times 4 times 4 is 64. 3 to the third, don't say 9. 3 times 3 times 3 is 27. So 64 over 27. Now, on problem number 4, we don't have a fraction to a negative power. So that will be, we'll just use that first rule. How do I have it written? A to the negative n. A negative exponent, if it's not a fraction, the way you simplify it, just 1 over a to the positive n. So in problem 4, to rewrite that using a positive exponent, you would just say 1 over c to the 9th. Now, what about going in reverse? Suppose you have the 1 over, and you wanted to write it without the 1 over, but the negative exponent. Well, just make the exponent negative. In place of this 1 over here, I'm going to write it like this. 3 to the negative 2. Okay? That pink 1 over becomes a pink negative. Y'all tell what I'm doing there? Like here, to rewrite 1 over c to the 5th with the negative exponent, the pink 1 over becomes a pink negative. Okay. Now, let's flip to the next page. So we've looked at a 0 exponent and negative exponents. What about a fractional exponent? What does a fractional exponent mean? Well, we've already seen this earlier this semester. A 1 over n exponent means an nth root. So a 1/2 exponent would be a square root, a 1/3 exponent, a 4th root, and so forth. A 1/2 exponent is a square root. Notice we don't really write the square there, but we sure say it, don't we? A 1/3 exponent is a cube root. 1/4 exponent is a 4th root, and so forth. Hopefully you get the pattern. A 1/5 exponent is a 5th root. The natural question to ask is, well, what if this top number isn't a 1? And I'll show you how to do those in a moment. Right? Number 7 says, rewrite without the rational exponent. It says in simplify, but there's really nothing much you can do. So a 1 over 9 exponent would be a ninth, oops, not an nth root, a 9th root. That's a 9, it's sort of hard to tell, of x. In fact, since it is hard to tell, let me write it neater. A 9th root of x. Now, number 8, rewrite it without the rational exponent and then simplify if possible. Well, a 1/3 exponent is a cube root. So we have the cube root of 64. And if you think about that a little bit, what number could you cube to get a 64? Well, a 4. 4 times 4 times 4 is 64. Okay, what if that top number isn't a 1. Well, if the top number isn't a 1, if you had something like this, a to the m over n power. That bottom number we already know is the root. Square root, cube root, fourth root. That's the root. The top number will be a power. So on problem number 9, let me show y'all how I'll do that. It's 81 to the 3/4 power. Let me go ahead and write this with a little bit of color. Oops, no, the wrong color. 81 to the 3/4. 3 over 4. Well, that bottom number, this 4, that's a root. So take the 4th root of 81, and then, you've got the 4th root of 81, cube it. The bottom number's the root, the top number's the power. Now, why am I doing the root first? Well, I don't want to cube the 81 first. If I'm going to do that, I'm going to need a calculator. The numbers are going to get really large. So y'all following the colors, 4th root of 81, then cube. Now let's see, what number could we multiply 4 of in order to get an 81? I'm thinking that's a 3. 3 times 3 times 3 times 3 is 81. It would be like 9 times 9. So we have the 4th root of 81 is 3. 3 to the 3rd, oops, grabbed the wrong color, it should have been a pink. 3 to the 3rd is not 9. What's 3 to the 3rd? 3 times 3 is 9, times another 3 is 27. Okay? So if the exponent isn't a 1, the top number isn't a 1, just do the root first and then raise it to that top power. Like here on number 10, let me do this. 16 to the 5 over 2, or 5/2 power. Well, I'm going to do the root first. It's a square root, so we don't have to write the little 2 that's there, but we assume it's there, right? The square root of 16, oh, that one's easier to do than the one we just did, isn't it? Then raise it to the 5th power. Well, okay, so that's going to get sort of large, isn't it? The square root of 16 is 4. 4 to the 5th power. Let's see, how would most of y'all do that? Y'all do it by hand, or would you just grab your calculator and punch in 4 raised to the 5th? So 1024. 1024. 4 to the 5th. Okay. Now, what about going the other way around? If you have a radical, can you write it with a rational exponent? Well, a square root is the same thing as a 1/2 exponent. So you would write 17 to the 1/2. Okay? Or you'll type 17 to the 1/2 if you're doing these problems online on MyLab. Ooh, what about number 12? Look at that. The 7th root of 23. The 7th root of 23. How will we write that as a fractional exponent? Well, I didn't actually write out 1 over 7. That's what this statement's for. The general statement, 1 over n is an nth root. So a 7th root would be a 1 over 7 power. Okay. Now, number 13 and 14, we're going to graph some exponential functions. To do that, I'm just going to plug in a few numbers for x. It's sort of hard to tell what these graphs, well, they didn't even print out one right here, it looks like. But them being on paper, I'll just draw it out for you. In general, graphs of exponential functions where the variable is in the exponent, the variable's in the exponent, they take on a shape that looks like this. It's a smooth curve where one end looks like it's flattened out and the other end is going up real fast. So it might look like this, or it might look like that. So to graph y equals 6 to the x, why don't I go get some graph paper? Hold on, I have it right over here. Here I am, back again. Sorry for the delay. I'm going to graph y equals 6 to the x. Y equals 6 to the x. The way we'll do this is just by plugging in some numbers. Keeping in mind, the graph's going to look like one of those shapes. Okay? So, if I make a little XY table here, I'm going to just plug in from 2 down to -2. How about that? So, plugging in. 6, if I put a 2 here, don't say 12, 6 squared is 36. 6 to the first power is just 6. Now here's a tricky one, do y'all remember? If I plug a 0 in for x, what's 6 to the 0 power? Oh, that's a 1. Remember that first rule I stated today? Anything to the 0 power is 1. Now what about 6 to the -1? Remember how to work with a negative exponent? 6 to the -1. A negative exponent means 1 over. 1 over 6 to the 1, so 1 over 6. Plugging in a -2, 6 to the -2, a negative exponent means 1 over 6 squared is 36. So to graph this, I'll just come over here and draw an XY axis. We'll assume each little mark is 1. Okay, so over 2 up 36. Oh wow, that would be way off the graph. So just remember, over 2 up 36. right 1 up 6. That would be right there. Over 0 up 1. Left 1 up, oh wow, 1 over 6. Could y'all imagine going up 1 over 6? Or what about left 2 up 1 over 36? See how it's flattening out? It looks like it's going to be touching the x-axis, but it doesn't. It just runs right out beside it. Formally, we say that this x-axis is a horizontal asymptote because the graph is just running out beside it. Something like this. And it goes up fast, if you can imagine. Right 2 all the way up to 36. So it's continuing to go fast. And this end is just flattening out there. Okay? Looks like it's touching the x-axis, doesn't it? And for some reason, no graph printed on D, but that's okay because the answer is C. When you're doing these on My Math Lab, you might want to go ahead and zoom in. They have the little option for you to enlarge on the graph, but unfortunately I'm just doing it here on paper. Let's graph another one. Problem number 14. Hey, there's another, one of the graphs not showing. C for some reason didn't print out, but when you see it on the computer, it'll be printed out. So, you know what? Why don't I make my table right here? This is where I'm going to put my XY table. And I'm going to go ahead and plug in the same numbers from 2 to -2. For graphing these, generally 2 to -2 is enough, provided that you know what the shape's going to look like, okay? One of those. But if you decide you need more points, then go 3 to -3 if you want. I think I'm just going to stick with 2 to -2. Now be careful, because there's a negative right there. Do y'all see that? So when I plug in +2 for x, I would have 2 raised to the negative -2 power. Don't say -4. Remember what a negative exponent means. A negative exponent means 1 over. Okay. So 2 to the -2 would be 1 over, and then 2 squared is 4. So 1 over 4. Plugging in a 1, we would have 2 to the -1. Well, that negative exponent still means 1 over. And then 2 to the first is just 2. Plugging in a 0, don't say 0. Anything to the 0 power is a 1. So 1. Now let's plug in a -1. Now be careful with this. When you plug in a -1, if you replace this x with a -1, you'll have negative, which is +1. 2 to the first is 2. What about plugging in a -2 for x? 2 to the negative would be +2. That's a 4. Do y'all see why I have the whole numbers over here and the fractions there, it's because there's that negative right there. I've sort of destroyed the problem, but it looks like this, 2 to the negative x. So if I'm going to graph this, go ahead and draw some grid lines here, and then we're going to plot those points. Let me see, how do I want to get it? Just like that. Here's my y-axis, and there's my x-axis. Each mark is each mark is 1 unit. So plotting right 2, up 1/4. This is the part where it's flattening out. Right 1, up 1/2. Over 0, up 1. Now here's the part where it's going up. Left 1, up 2. Left 2, up 4. So if we went 3, left 3, it'd be up 8, and so forth. This is what sort of going up fast, and over here is where it just starts flattening out. So that is, well, it's gonna, nope. Oh, it must be this one here. For some reason, some of these aren't printing out, and it would be C. For some reason, it didn't print out, but on your, when you're doing the homework, it should show there. Okay? So it looks more like this. This is a much, right here, that's a much better curve than what I drew here in this little space, something like that. Okay, well, look at it here. Maybe that's what they say, graph it on paper. Okay, and then choose the correct graph. Here it was just so small. For some reason, some of these didn't print out, but it has to be this one there. Okay? Why don't we go take a break, and we'll start solving equations, exponential equations, using a common base in a little bit. Okay? To finish up this assignment. So thank you for watching. This is Mr. Precella. Bye-bye.